Okay, can everybody come in and sit down, please? We're going to get started on block 3. Right. It's the final countdown. We're on block 3, the last part of the event today. It's the final set of discussions and presentations. We're going to keep you rooted in your seats or watching your screens until it's time for networking and cocktails in an hour and a half. Right. Block 3 is really about talking about the successes of FLPP and how you can work with us. Good here. And how we can coordinate and how we coordinate with other European institutions on some of the key topics, such as in-space logistics. FLPP has existed now for over 20 years and has contributed to many industrial successes. However, it's been difficult for us to get the visibility on the concrete results that we've been creating within the European ecosystem. Our events give us such an opportunity to present to you these concrete results, and we decided to introduce a new session that we're going to repeat for each spring and autumn event, where we'll promote some of the most recent successes we've had in the projects we've had. And to run this first inaugural session, I'm going to welcome my colleague Bernardo Cottini on the stage.
Hello everyone. As Kate said, thank you, Kate. I'm Bernardo Cottini, and I will moderate this session during which companies will have the opportunity to present their achievements. Merci. The achievements they have had under FLPP's contract. As Kate said, FLPP is existing since more than 20 years, and along all these years, a lot of great successes have been achieved. We can quote the first test of the Vinci engine, which is now on Ariane 6, as you know, Bertha design and demonstration, and now under Astris development, precursor activities with SCORD, maturation of the IXV, which have been launched in 2015, and more recently, Phoebus, Themis, Prometheus, and Phoebus linerless composite cryogenic tank. So we have decided to dedicate a part of our FLPP session to these successes. The objective is to provide more visibility to the technical success and to congratulate for sure the companies, and also to promote a technology with potential commercial cooperation. For time constraints, we had to pick 4 companies, and it was not an easy task because we could have selected 10 or 12 activities with recent interesting technical outcomes. And this is why this section will be repeated for the next session in autumn. So you will see other successes in October. We will start our presentation with a Swiss company, Compare, who is developing high-level composites with repair system incorporated. So let me call on stage Cecilia, Amael, and Robin for their presentation.
Good almost evening to everyone. It's a great pleasure to be here today to present you more, first a little bit about Compare, but most importantly the Cassandra project and beyond. We've been discussing quite a lot also today and over the past times about the targets and the routine and cost-effective access to space. And reusability and cost-effective maintenance, we truly believe can be achieved with self-healing materials. And this is exactly what we are doing at Compare for specific applications. So first of all, who is Compare? What we do is that we offer healable products to extend part lifetime, specifically around composites. We are a Swiss-based company based in Lausanne with above 20 team members into the company. As we are a materials provider, what we do is that we develop and we sell semi-products, specifically pre-impregnated textile, to produce healable composites. This is made at industrial scale. We have part of the production in Switzerland and ports around Europe with partners. As we are a composite provider and materials provider, we can target quite a wide range of applications. And we like to say that we have two big pillars of work from aerospace and mobility towards sports and leisure. We could demonstrate several benefits around economical benefits thanks to the repair, but also environmental benefits. And to tell you more about how it works, the repair, and more details about that, I will hand the floor to Robin, CTO of the company.
Thank you. So some of you may be familiar with composites, but it's mainly fibers or textiles that are stacked upon each other and embedded in a resin. And we have been developed different types of resins. And those resins, they have the unique capability to heal themselves upon a small heat trigger. Composite, they're great, they're lightweight, they're stiff, but they're quite sensitive to damage, and that's where we come. We are able to repair, regenerate the properties of composite part up to 100% of its original mechanical properties. We have an enhanced crack resistance, which is very useful, specifically for lower temperature applications. And we have also good damping properties, meaning that we can also have lower vibrational states. You have several types of different damage. The first one you see on top there, it's called the delamination. It's basically the matrix, the glue that it's cracking between the different layers of fibers that you have. Can have a dent, can happen on sandwich panels where you have foam cores or honeycomb cores, and simply scratches, and we're able to heal them. You have here a small demonstration. It's a typical aeronautical part. We impact it with a steel ball, and here at the center of the screen, you can see the delamination. And simply here with a heat gun, we trigger the heating mechanism, and we are able to bring back the original mechanical properties. Focusing on space, there are several potential applications. Any composite parts in your reusable launchers that could be repaired during the refurbishment phase, for example. There are in-orbit refueling stations, satellites, but currently we are focusing our efforts mostly on propellant tanks. The story of the propellant tanks, the current state is that they're quite overrated, and you have 5 different types, and the higher number, the more composite you have in your tank. It's great because it's becoming lighter, but it's also quite sensitive to damage, and you have micro cracks and delamination that could appear during the manufacturing and the use phase. So to answer that problem, I will handle the floor to Techi.
Thanks a lot. And here you see the solution that we propose. So our HealTech composite materials could really answer this need and tackle this challenge. Here you see on the left, these materials have a superior resistance to microcracking, as mentioned before by Amel and Robin, induced by thermal shock cycling typically. And here on the left, you see we have done tests up to 10 cycles between minus 196 and room temperature, and no microcracks were observed. And whenever we reach the stage where these microcracks will arise in the material, we can simply repair that with the aid of heat. And you can see an example, a demonstration on the right, typically with ultrasound analysis in this case. And this is why we have been working a lot on this specific use case where we see a lot of added values that our technology could bring. And we've had several projects in collaboration with the European Space Agency and different space industry stakeholders. We started really highlighting with the first project highlighting this use case, a second project where we really focused on developing a material and really a product specific for space applications and for cryogenic tanks in particular. Then we have been working within the frame of FIRST on the Cassandra project, where we partnered with Common Sense and CSEM to achieve autonomous damage sensing and healing. And another project that we have currently running, it's still within the frame of FIRST. And here we're focusing on really increasing the maturity of our sleep tapes for cryogenic tanks, typically looking at compatibility with liquid oxygen and different type of propellants. But for now, let me tell you a bit more about some of the key results that we were able to obtain within the frame of the Cassandra project. And so let me start by telling you a bit more what we did in here. So we took our Hilltech composite materials, our healable composite materials, and we introduced optical fibers, thanks to the aid of common sense, to achieve health monitoring, and metallic heaters to be able to trigger the heating and the temperature we need for the healing in a fully autonomous way. And the addition of these two systems only entails minor additions in terms of weight and costs. So typically below 1% in terms of weight and below 15%. And now let me show you really some of the key results. So here on the left, you see that we really efficiently locate in a precise way the defects, the damage, with a maximum error of 4 centimeters in an autonomous way. And on the right, you see thermal images that really allow you to have a perception of how homogeneously we could trigger the heating between 100 and 150 degrees to achieve the healing. And we could prove this healing also from a mechanical point of view. So now you will see on the right, in the next slide, a graph showing you the performances that we have in terms of mechanical performances in the material when it is in its undamaged state, in blue. In gray, you see that these performances decrease, of course, when you create damage in the material, and triggering the heat. Thanks to the integrated heaters, we could recover up to 92% of the initial performances. So we could really achieve autonomous damage sensing and healing to unlock the potential to do maintenance in an easy way, for example, in orbit. And with this, I will hand back to Amal.
Yeah, thanks a lot. And so to close on, what are the next steps after this project? Now it's really getting to a full-scale demonstrator of a tank, integrating autonomous damage sensing and healing, reaching TRL6, and further commercial implementation of those solutions. There is one element, yes, it can match the ELC timeline, but it can match also various types of roadmap, which we would be delighted to discuss with all of you during the apéro right after. To build the world of tomorrow on Earth and above. Thank you very much. We were really delighted to present today. Thanks again for the support of FLPP within this framework, and looking forward to the next step. Thank you.
Thank you very much. Don't go too far because we will need you for the photo. For our second presentation, another project with composites, with ATG, who is developing a lattice structure for multi-payload adapter. So I call on stage Mr. Brendan Murray, where is he? Who has technically led this project for ATG.
Good evening, everybody. So, yes, so on the frame of the first project, we did a composite multi-payload adapter. Yep, better? There we go. Sorry, technical difficulties. In regards to our first program, we looked at a composite multi-payload adapter with ourselves, ATG Europe, Leggio Ruffischini, and ASI, the Italian delegation who gave us funding for this. So to give you some background on ATG first, we've been in the space industry for over 50 years. We have premises all across Europe. Our headquarters is in the Netherlands, but we have offices in France, Italy, Ireland, the UK, Germany, among others, and we have over 50 million euro net sales per annum. Over 500 staff now, and over 30 different nationalities working in the company. Our main business is manpower provision, so we put people in high technical applications or high engineering skills into roles with major primes, including ESA. But for this project, we are working with our in-house engineering consultancy services business. So for the composites team, based out of ATG Italy, we were progressing our proprietary composite lattice or grid stiffen technology. So again, if you haven't seen this before, we combine the major aspects of a carbon fiber material and the lattice architecture. So the carbon fiber gives you your high strength material properties in a single direction in the ribs.
and your lattice architecture gives you your mass optimization capabilities. So we get to create a lightweight part for space applications. The main benefits of our tech are that we do not interrupt fibers at the node. So fibers are continuous. We maintain the strength of the CFRP material then throughout the structure, and that gives us better performance in comparison to other technologies. In addition, with this image on the right, we do a one-shot manufacturing process. So our composite structure you see here on the right, the lattice, the skin, the patches, the laminate sections, everything is manufactured in a single autoclave run. So there's no secondary bonding, no secondary manufacturing steps. Everything comes out as a near net shape part. In addition to this, we offer mass savings with this tech of between 20 and 60%. If you come to us with a very stringent design that can't be changed much, we can still probably offer you 20% mass savings, which is pretty good. If you come to us at the start of your development run and give us a bit more freedom, we can get down to that 40 or 60% range. So for first, this image on the left is probably, everybody here will probably notice it. It's from a Falcon launch of a rideshare mission. So rideshare uses these large metallic rings to hang small sats off of them, and they'll use that as the major interface for the payload itself. This design came from Moog, so the gold rings on the right, where they were using it's called an ESPA ring, an evolved secondary payload adapter. So in your mission where you have a large satellite, you would then put an ESPA ring on the bottom of it. You could hang small sats off of this for your launch, so you get more efficiency out of each launch, more payload launch with each launch. We took this design and we looked at it and thought that this is very heavy. So obviously metallic structures are much heavier than composite. And we thought that this could be a good application for our lattice grid stiffen technology. So we used first as a launch pad or a backbone study to assess if this would actually be a good application for our tech. We looked at compiling all the requirements for ESPA components. We did a design and iterative analysis approach for different ESPA variants with our CMPA design to see if we could actually meet the same performance. And then we compared it to their metallic counterparts. We also de-risked this technology by looking at the port application. So this would be a new design capability for us where we have the port integrated with a cutout in our structure. So this was kind of what we used first to actually assess. And we did a market assessment to see if we'd actually have a good business case for this and a return on investment in future. So for the results, were quite good for us. So we actually show that we have equivalent performance to metallic ESPAs for our CMPA variant. So that's with 7,700 kilos of primary payload above the ESPA structure, above the CMPA structure, and then 700 kilos or 450 kilos for your small sats that would be the secondary payloads. We did this for Falcon 9 loads, so QSL, buckling, modal, sign, everything you would need to launch on a Falcon environment. Basically, our structure can perform to the same level as its metallic counterpart. We're offering mass savings of between 20 and 40% against those ESPA rings. So depending on how big your structure is or how what size ports you'd have in it, we can actually offer you more mass savings. It really just depends. The more carbon we can actually get into the structure, the more mass savings you would get. We also did this port samples here on the right. So they're 2 scales. That's a 15-inch port design. And we took the global parameters from our global models for the lattice and did tests on these TBB samples and showed that we had good correlation against our predictions. All this showing that to use first as this kind of launch pad for moving on to another project in future and using this as kind of the backbone for developing this further. And that's kind of one of the major successes of first for us is that we've actually gotten a full FLPP project based on this initial work. So this year, we're going to be continuing the global and detailed analysis of these structures. So in 2026, in 2027, we will move to manufacturing a qualification model. And then in 2028, we will test it. So this will be the first commercial off-the-shelf component that ATG will offer to the aerospace market. But there are other applications for this. So obviously we talked about payload adapters there, but we're looking at central tubes for lunar landers, orbital transfer vehicles, dispensers, adapters, anything that has a need for mass optimization, which is where we're looking for here. We're looking at it as a modular component. So we want our CMPA structure to be plug and play for your satellite designs. You can use this as your skeleton for your spacecraft or for whatever application you need. And we can still offer you 40% mass savings, as well as putting material or patches or attachments wherever you need them. So if you come to us with a tank mount or equipment that you need in a certain place on the structure, we can provide that to you. So that's basically the long and short of our project. I'd like to thank ASI for providing the funding for this for our ATG Italy team. It's really allowed them to kind of move forward with this design and make multi-payload adapters their niche for our technology. To Bernard, had direct contact with, and I cannot speak highly enough of FIRST in that regard. For the contract and the technical side, we went from FIRST for ITT issued to contract signed within 3 months. So that is unheard of for me in any ESA program I've ever been in the past to have work being done within 3 months. So I can only thank Bernard for all that. It's been amazing for us on a company level. And finally, our manufacturing partner, Leggio Refraschini, based in Milano in Italy, FIRST also allowed us to develop our manufacturing methods with them, but also integrate our PA/QA aspects. So really de-risked our project moving forward this follow-on FLPP project in the near future. So very thankful for you all listening to me ramble for a little bit. Hopefully it was somewhat interesting. And yeah, thank you very much for your time.
Thank you, Bernard, and thank you also for the words. Yeah, I'm very pleased to continue this work with you and with ATG, and hopefully in the coming years for the qualification. Our third presentation is Arcadia Space with Mr. Francho Garcia. It's a well-known Spanish and successful Spanish company developing and producing thrusters for space transportation. So,
first of all, thank you very much for all the FLPP team for giving us the option and the possibility to present our company. Arcadia Space is a propulsion company doing technology, thrusters, and all components, but valves using hydrogen peroxide. That is our technology. It was founded 5 years ago by the propulsion team of PLD Space. We were the first employees over there. And right now we are a team of 26 people, but reaching 40 by the end of the year because of all the commercial contracts that we need to deliver right now. We have 4 contracts with the European Space Agency. FLPP has been the program that has supported us the most. We have one contract with the Spanish Space Agency and 3 commercial contracts already. And since last year, we're already in space, being the first company in Europe that demonstrated successfully propulsion technology with hydrogen peroxide. We have been invested by relevant people like our astronaut in Spain, Pedro Duque, but also Antoine de Chessy, the founder of Loft Orbital, a well-known person here in France, and also some VCs from public sources like the Ministry of Science and Innovation, paper in Spain, but also expansion here in France. What do? We do thrusters. We started with the monopropellant technology. We have 2 engines, 250 Newton monoprop and 5 Newton monoprop. The 250 Newton monoprop has been supported by FLPP and is the story that I will tell you right now. Monopropellant technology, decomposition reaching up to 180 seconds of ISP. Then we have also the biprop technology. In the case of Arcadia, we bet on epicolicity. So we want to really be the replacement of hydrazine and MMH. And we took the challenging road, which is developing our own epicolic fuel. This engine, the 200 Newton, has been also supported by FLPP. As I was mentioning before, we don't only do thrusters, we do the electronics and the tank so that the customer doesn't need to take care of anything. We provide to them complete propulsion systems. And the idea of Arcadia is to serve the whole value chain of space transportation. That's why we are here. We can provide propulsion systems to satellite, all kinds of innovative servicing vehicles for RPO maneuvers, launchers, which was the first commercial contract, re-entry vehicles. I will announce soon what is our next big contract. And hopefully one day we will go also to the moon with hydrogen peroxide. In fact, you see here, there, the 3 contracts that we have already closed. 2 will be announced soon. Another one is coming right now, and soon another one with an American company. And the reason why we have been so fast up to now is because we count with, I would say, the most relevant and technological advanced testing facility at private level in Europe. Everything developed by us. Right now, we have 3 test benches. Next year, I will tell you, will be the most advanced private testing facility in Europe, able to do whatever test below 1 kilonewton. And why we are different from others? We have 3 value propositions. On one side, we can reduce a lot the cost drastically, not only because of we can be efficient in the system development, but also in the operations. You remove the toxicity of hydrazine, and then you can reduce drastically the operations. It's something that we already did for the first time in Europe, in Vandenberg, when we launched last year with SpaceX and our friends of the Orbit. Thank you for that, the Orbit. How we can pass from 500,000 to 2 million to less than 50K. We also have a much performance. With hydrogen peroxide and an hypercolic fuel, you can really replace hydrogen. We can reach up to 310 seconds, and we have an ignition delay time of less than 50 milliseconds. And here there is a test that proves that we did through FLPP, which there is no sound, which is a pity because it pumps very strongly. But at least you can see that we also do green propulsion. Then is the time. So we are able to deliver in less than 10 months. The mission that we did last year, we did everything from concept to the actual integration in 7 months. When we started, we had nothing but a prototype of the thruster. The valve was procured from our fellows of Delta Vision. The rest, it was done by ourselves, the tanks and the electronics. And in March, in 1 year, we did our first launch, which was successfully demonstrated in April when we started the operations. In fact, we don't know any other company in Europe or in the US that in the last 20 years have been so fast in passing from foundation to actually demonstrating operation capabilities in orbit. And that's what we did with our first customer, MySpace, that rely on us. We closed the contract at the end of 2024, and by September, we already delivered the first 4 units for their RCS thruster that hopefully will launch soon. But let's gonna start talking about why we are here. The story about Ariel, which is a 250 Newton monopropellant thruster. We need to say that FLPP bet a lot on us because when we got the contract, we were a team of 9 people only. We just had a very little test facility, and it was just 1.5 years since we got our first money, and we could do things. And by that time, FLPP team supported us and believed in the fact that we could scale our very simple 5 Newton monopropellant technology in something bigger. That was the real contract. The real contract was supposed, and it did, develop a thruster for the next generation of launchers running in hydrogen peroxide. We got several requirements at system level. We had to develop the thruster, but also a prototype of a tank. And the challenge was to pass in very short time from 5 Newton to 250 Newton. And it was very little money for the development of the contract. And of course, the test bench was not included. We developed the test bench in parallel in less than 6 months. And this is the timeline that we had for the first demonstration. In June, we closed the contract. In October, we were already testing a prototype of 40 Newton. In December, we already finished the test bench to do the demonstrations. And already in January, in very short time, we were doing a 1-minute continuous firing successfully demonstrated to ESA. And then from that point on, we continue maturing the technology until we finish. These are the capabilities that we demonstrated through this contract, different pressure inlets for different thrust levels. Also a very good throughput that you know that sometimes for the catalytic beds is a challenge for hydrogen peroxide engines. Roughness that now is much more improved. This is just the results of the FLPP, a lot of pulsing, and then the manufacturing capabilities. What has been the impact? And with that, I'm finishing now the presentation. We now have developed a much better engine, which is the version 2.0. What we got from the Maya contract is 3 times the value of FLPP contract. So we are really creating value out of this activity. And then because of that good performance that we had with Ariel, we got the subsequent contract to develop the bipropellant technology. But the most important thing was with whom we have signed contracts after this activity, which is MySpace, the big launcher program, but also Dassault Aviation. We are the propulsion partner for Dassault Aviation based on the engine that, thanks to FLPP, we developed. So we cannot be more than thankful for FLPP, because if we are having now this credibility, these recognitions, is because of them. Thank you very much.
Thanks a lot, Francho. Don't fly too far. We will need you for the picture. Yeah. Thank you. If you need thrusters, it will be available during the apéro. Yeah, our last presentation will be done by Orbital Paradigm. Francesco, you're there. With this success of the KIT project, so it's come and the floor is.
Thank you so much, everyone. Well, so I'm Francesco. I'm standing between the drinks and you, so I'll try to be quick. We had a bit of a crazy story because we're a company devoted to reusable in space transportation. Our goal is to be able to do in space transportation, come back to Earth and reuse. And we started with something very, very small, which is a small capsule called KIT. This is the things that we're trying to do. We're trying to get we're getting to Kestrel. The first demonstrator is called KIT, 22.5 kilogram small capsule that we launched the 12th of January, and the rocket failed, and in a very unexpected way, we received telemetry nonetheless. And we published that the rocket had failed, but our mission had functioned, and I guess this is hard to believe, probably. So we did a full post-flight analysis trying to explain and reconstruct what had happened, and we published it, and it's public. So I'm here to tell you about this crazy story. So being a re-entry company, we try to explain in detail what is the whole sequence of events that went from a failed rocket launch to us receiving telemetry of an hypersonic re-entry. And I think I always say is that there is no way we can know exactly what has happened. We have 3 minutes of data that we've reconstructed, and we think we have a very good explanation that demonstrates that we got very good results and that KIT worked. This is KIT. It's a small capsule that we built in less than a year. We started 4 people, finished 9. We spent less than $1 million, including salaries, hardware, testing, and launch, and liters and liters of coffee. And we wanted to demonstrate 2 things: that we could carry some customers' payloads. Flying empty is hard. Flying with a customer is way, way harder. And we wanted to demonstrate a bunch of technical things that in the end mean that we can build and successfully fly a functioning re-entry vehicle. And we wanted to learn. And this is KIT on PSLV. We launched KIT with PSLV C62, return to flight. In my optimistic mind, I thought, okay, if a rocket failed before our flight, they will have fixed it and it won't fail again in the same time. I was wrong. Because when we were watching the launch on the 12th of January, we started seeing the upper stage of the launcher tumble. And I always say that I experienced fully denial because I thought it was just a glitch of telemetry. And I hoped so strongly that it was a glitch of telemetry until it was clear it wasn't. And then we published this, that this thing made the news, right? The only spacecraft that survived a failed rocket launch. And many people in India wrote to us, out of curiosity about this. And this is what was supposed to happen. We were supposed to be launched by PSLV, stay coupled to the launcher during the orbital phase, deploying payloads, and then at the end there would have been a deorbiting maneuver. And when we were already pointing back to Earth, we would have separated the flow half an hour, more or less, outside the atmosphere, and then a re-entry flight. And the reality is that the launcher had, I'm saying failure here. I always say non-nominal launch to be kind, but it was a failure. Okay, and it happened around 400 kilometers of altitude during the 3rd stage. PSLV has got 4 stages, and the first lucky thing that happened is that the fairing of the rocket was already open. So the rocket kept thrusting until 500 kilometers of altitude. As far as we know, the 3rd stage separated, and the 4th stage switched on and kept thrusting. And then after 10 minutes after the failure, I gave a speech to the company saying, okay, guys, come on, it's hard, it's space, things fail. And then one of the guys this was 5 in the morning. I was really trying to understand what was happening, but one of the software team told us that we had telemetry, and I again thought it was a glitch. And then we received 5 data packages with more than 3 minutes of data. And so at 5 in the morning, we started looking at what has happened. And this is the data we received. It's 6 packages, of which the first 2 are empty because they are connection established. And we had 2 transceivers on board. Unfortunately, we could only retrieve data from one. I will explain at the end why. And this is the data we got. It's public. So if some of you are curious about it, want to learn more, just have a look. There are a bunch of re-entry experts in Europe. If you have questions or disagree with our conclusions, let me know. I'm happy to review them. But you can see that the data packages, and we have acceleration, we have orientation, and we have temperature of the payload and temperature underneath a tile of thermal material, ceramic tile of thermal material that we're developing in-house, and we could retrieve the temperature underneath our own thermal material. And we also had location data. This is not GPS, so we had approximate location data of where the spacecraft ended up. So we did a reconstruction exercise, and I will try not to bore you too much, but basically we got the data from the launcher to understand the initial point. We had a simulator in-house of the whole dynamics outside the atmosphere and inside the atmosphere, and then we had some flight data. And with the flight data, we had some very specific acceleration and time events. We had the time at which the first data package was received, the time of the last data package, and we tried to say, okay, we have a whole set of initial conditions that we can explore. We will simulate them and filter out those that do not match the data. And we keep those that match the data and try to understand what are the most representative and the ones that make more sense. And we had to add an artificial maneuver to represent the fact that PSLV was pushing and tumbling or re-entering, because otherwise there was no way of getting any feasible solution. We did a lot of search space research and basically get into the interesting stuff. The most probable entry angle, so the angle between the trajectory and the horizontal, was around minus 20 degrees with a variation between minus 25 and minus 17-ish, and a velocity between 6 and 7.5 almost kilometers per second. We were expected to re-enter minus 1.5 degrees at 7.9 kilometers per second. So basically we got in a little lower, a little slower, but way steeper. And this is normally a problem because what happens is you get very high accelerations, much higher. This is key. And the first thing that we thought, okay, how can we have telemetry? Because to have telemetry, we need to have separated. The antennas were on the back hatch, and the thing needs to have switched on and point the right way. So we tried to understand what are the reasonable separation conditions, and we saw that most likely what has happened is that while the upper stage was tumbling and coming back through the atmosphere, it hit the atmosphere. And for a vehicle with the shape, for a solid with the shape of the upper stage of a launcher, it is reasonable to find a stable attitude while entering the atmosphere. And we checked and we saw that with the orientation, the material properties of the separation ring from our friends at Works, it is reasonable to have a temperature profile that you see in this slide up here. Shows, it doesn't show. Okay, well, the one on the lower part of the plot. And here we were lucky again because the separation ring is based on a thermal mechanism. So normally you would give a command and it would open, and no command, but the temperature raised up above the opening temperature before the loads. So we think it was a clean separation due to these heating from the atmospheric re-entry. And we saw some very interesting things for us. We flew a stable flight during hypersonic phase through Mach 20 down to Mach 3. We went with above 32 Gs of accelerations, and trajectory reconstruction shows as high as 40. Heat flux was twice what we had designed for, but of a shorter pulse. And we have data packages until very close to the splashdown. We think the separation altitude was around 60 kilometers. You will see at the end. We tested and we got thermal data from our heat shield sample. This heat shield material is now being evolved with a contract from FLPP, and we're very happy about that. And we were able to reconstruct with the thermal flux and inside and outside temperature the whole thermal profile of the flight. And there you go with all the trajectory results. This is a bit of nerdy stuff, but it shows that we had very worse condition on everything, but on heat load because the flight was shorter than expected. But yeah, I finished with a few thoughts that I had myself, and I got asked, did we get lucky? I don't know. You found a company, spend $1 million, and then the launcher fails. You don't really feel lucky. And those that have had a launcher failure don't feel lucky. Then it's true that the rocket didn't explode, that the separation mechanism was based on temperature, that we hit the temperature, so we got a bit lucky there. And then the capsule withstood way worse condition than it was designed for. So we did a good job there. Even though it was designed to withstand 11 Gs, we withstood 40. So was it a bad design? Not at all. It was designed to withstand suborbital conditions at the beginning of its design. And then I really think that it didn't make any sense to try and optimize and shave probably a couple of kilograms of aluminum to optimize the structure, and it was worth it. Some people told me, oh, but it was a small capsule. Yes, if it had been bigger, it would have been way easier to manufacture because everything was very cramped in there, and thermally was way more complex. And did we learn something from the mission? A lot of stuff, and we're very happy because in the end we've proven that with our design models, all that we did, we can have a functioning re-entry spacecraft on a shoestring budget. So very happy about that. As I said, we tested some stuff on kit that is related to the onboard autonomy we're developing with FLPP, as well as the thermal protection material. Thanks a lot, and sorry for being a bit too long.
Thank you very much, Francesco. It ends our presentation. This successful have been possible thanks to the support of ESA team as well. So Kate was there, Johan, no, you are there, and we are from tech colleagues Donato and Ferran. And I don't want to forget our PA colleagues, Lorian and Marie-Pierre. So yeah, if you can join me on stage for the final picture.
Thank you.
Thank you. And Kate, I give you back the floor.
Thank you very much, Bernard. Thank you so much for that fascinating discussion and those presentations. While I was listening to them, something came to mind, which is we didn't know it was impossible, so we did it. We didn't know it was impossible to go from ITT issue to contract signature in less than 3 months, so we did it. Arcadia didn't know it was impossible to go from a design to a system, a flight system in 9 months. Orbital Paradigm didn't know it was possible, didn't know it was impossible to survive a launch failure, so they did it. So this is a really great example of the programmatic and the technical and the commercial successes we can actually do when we refuse to believe something is impossible. And what we've seen today is real commercial successes building on FLPP contracts and European companies and startups being commercially successful in Europe and worldwide. So I think we can all agree that was a fascinating presentation, and I'm really looking forward to the next one we have in the next session to learn more about further successes. So next time, now we're going to go up into space and stay up there. We'll talk about in-space activities. In-space activities have caught the attention of various actors at a European level. The European Commission talks about ISOS, so in-space operations and services, and ESA we talk about ISAM, in-space servicing, assembly and manufacturing. What is important to remember that there is space transportation is the backbone of this activity. We need to be able to move around in space, and we need to be able to support a logistics infrastructure. Given the interest of all the various actors in Europe on this, how can it work together? How can we get the optimal result for Europe by working together? So I'm going to let Daniela come on stage to present that to us.
Good afternoon, ladies and gentlemen. Thank you. Yes, sorry. This is an easy one. When I thought that the audience will be sleeping after such an inspiring presentations, it's really a pleasure to host the upcoming panel. But allow me only a couple of seconds before we start with the panel. Today was a demonstration of what an institutional power of technology competence and drive can move, and all these credentials that the young companies mentioned on stage was not something that is directed. I have had the pleasure personally to support some of these young companies, and I can tell you this is a very hard job. But what actually makes the biggest and the most successful mix is when everybody is working together in collaboration. And this is what our panel is about. Our panel is about the two biggest European institutions in space working aligned together, hand in hand. So I would like to welcome my panelists on. Gentlemen, please join me on stage. And a big round of applause between this interesting panel and the cocktail. Please, are you sleeping? So I guess most of you know this gentleman, but please allow me to introduce them. Starting from the left, of course, we have Jérôme, who also had the pleasure to also open our event today. And I think you mentioned this panel. Thank you very much for promoting it. I'm very happy to welcome Daniel Nölke from the European Commission, DG DEFIS Space Single Market Unit. Very nice to have you here, Daniel. Tiago Soares is joining us from ESA Space Safety Program, or ESA Ops, as many of you call. And last but not least, Christos Patsis from the Commission, DG DEFIS Space Single Market Unit. Welcome. So, as Kate mentioned, we will be talking today about ISAM and ISOS, and I'm absolutely sure that most of you know what it is, but allow me nevertheless to repeat it again. ISAM is In-Space Servicing, Assembly and Manufacturing Program of ESA, and ISOS is In-Space Operations and Services, and both programs are united in fostering new in-space economy, the new in-space economy. And to start with, Jérôme, you had the possibility to open the event earlier. It felt like very shortly ago. You talked about orbital infrastructure in space transportation as a critical strategic asset for in-space economy. What is the FLPP perspective in that sense? And maybe you can open the discussion a little bit out of this fantastic content that we just heard today, the whole day, on the picture from the space transportation, and what is the role of in-space transportation as a key enabler?
Thank you, Daniela, for the question. Yeah, that's a huge question. So, but I know we are time constrained, and I would like to leave the floor to my colleagues so that they can develop. I will start from because today is a space transportation event, but we are discussing of in-space, space logistics, in-space activities, because we see the first development, I would say, of typically the orbital economy, and for example, with what is called the space data layer, pertaining to edge computing, artificial intelligence, intersatellite optical links, and so on. So we see this quick and rapid development of this activity, speaking typically of Golden Dome in the US and so on. So we see all this, which is quickly developing. Why do we speak of this today, and why are we a key actor? I would say have a special role. We space transportation community in this domain. But it's very simple. It's because all this is developing because the space transportation and especially access to space is becoming routine. There is a dramatic or drastic, I would say, a decrease of the access to space cost, becoming marginal. And with this, we see the quick development of all what can be done in space and what is needed to accompany. Because space transportation, if we limit our activity to the access to space, we only tackle part of the problem. And if we want to cope with the challenge of the development of this orbital economy, we need to ensure end-to-end space transportation. So access to space, transport in space, return from space, and with all the associated capabilities, because we have, if you think about it, and if you think in this way of end-to-end space transportation, then quickly arises a need for space storage capability, refueling, quick payload transfer, which are capabilities which we don't master in Europe. So that's, I would say, the link, and I use it as a bridge to hand over to my colleague and to develop, I would say, in space activity. But we need, you see it around me. Our conviction is that we need to quickly develop in Europe a certain number of capabilities to cope with this need for end-to-end space transportation. And the question, and I raised it at the very beginning of this today's event, we have to see the interest to have a transnational approach, because we see that there is clearly an infrastructure of common interest at European level that could advantageously be taken and mutualized at European level, while leaving to, for sure, the national competence develop the effector part, so in a complementary approach. But voilà, in a few words, I would say the missing link between all our space transportation event and discussion of today and today's topic of ISAM and ISOS.
Thank you very much, Jerome. Before we continue, I would like to address Tiago, but please feel free to come into dialogue. We have been discussing that. I think it will be nice to have a lively discussion between yourself. But before we continue with the initial statement, Tiago, you have two serious roles within the European Space Agency. You're heading the clean space and circular economy, but also you're chairing the ISAM working group. And I think taking from what Jerome just described, can you share with us a little bit, also with the help of this slides that our audience is looking at the moment, how do you ensure this coordination? How are these different elements working together?
Thank you, and thanks for the invitation to be here today. So starting with, I think, just a few words and building on Jerome's introduction on how this is important also for ESA, but also for Europe in general and for the European Commission alike. ISAM has really a transformational potential. That's how we see it, I think, in both organizations. It is across boards. It's not limited to one application. It is multi-actor, multi-purpose, and this brought us together as well, in the sense that we need to, and we have started now for months to meet regularly and work together on how, what would be the European vision to bring this transformation that will change virtually everything, how we conceive sustainability in space, how we conceive the value chain, the value of the assets that are already in orbit, how can we actually use it for other purposes. So this is a very important element in which I think Europe has right now a unique opportunity to really have a strong word. What we see in this slide, and it's really putting together what I think was easier than we expected, that is, there was from the beginning a common vision of what space architecture should look like, where we have elements that are dedicated to the servicing or end effectors. We have elements that are dedicated to the hosting, storage, if you want, in space, and logistic elements that serve and bring these assets to space to be then used in actual use cases, by actual customers. And what you see in this slide, actually, so going to the slide as you requested, you see a very good match between what ESA was doing in all these elements and what is the vision also for these ISOs in space infrastructure. And I think here we are now in the phase in which this makes a very strong, even stronger case, I would say, for collaboration and cooperation, because these missions should be taking advantage of each other, being it whatever funding source, or as Jérôme also said, opening to even national programs to plug in and to use this infrastructure. We need to capitalize on the efforts that are being done on the different fronts to build in space infrastructure that is usable and useful for the overall space sector and community in Europe first, but also for the rest of the world.
Thank you very much, Tiago. You started already describing your cooperation. Tanya, can you share with our audience the European Commission's ambition on ISOs? I know you and Christos have been working on that for quite some time already. Even though you come not so far away from Brussels, sometimes the distance feels a bit longer. But I think sitting around together and talking about these things, this shows really a very close collaboration. But coming back to the ambition, where did you start?
It's a good question, but it deserves a bit longer answer. I fear not a compact one, but I try my very best.
We can try to continue at the cocktail.
To be really brief on this, but thank you first for the invitation. I'm very pleased to be here with you and sharing our thoughts here together with the distinguished colleagues here at the panel. So basically, to understand what is our, let's say, driver behind what we started with is a couple of years ago already to really to find a good narrative and putting these things together, because we know from historical reasons that we have here and there individual missions, basically tech demonstration, etc. But this is normally out of visibility, especially at higher decision-making levels. So this is why we had to create something that people, I mean, not only decision makers, but also member states level can identify with basically and find a role in it. So, and this is what we did, starting by let's say, using a strategic capability that we call ACT in Space. So this was really 2024, where our commissioner really used this for the first time, this term, for two reasons. Namely, the drivers here were clearly to protect the infrastructure in space, so support to the protection of the infrastructure in space. And the second is the enabling and the capturing of the in-space economy. So, and this was a driver. Now we have a third driver, which is basically contributing to support the protection of the space environment. So this is clearly the third pillar. So these are the main drivers. But then there's still the question, how really to formulate something, not only on a mission basis, but really think a bit bigger, and how to implement. So, and this is why we came up with the idea of thinking about doing a shift from individual mission towards the, let's say, service infrastructure development and then deployment subsequently. So, and basically this idea of having a service infrastructure that embarks or can embark basically players from private but also public players that offer and address use cases for commercial, institutional, but also governmental aspects. This was key here. So meaning we are talking about a scalable, modular, expandable, basically service infrastructure, a European in-space service infrastructure that is capable to address basically various applications. So this was the idea, and this is a bit one aspect, and this was already raising the attention at political level. So, and based from that, we had an agreement at the highest level. So we started to sign joint declarations between Commission and member states that shared this idea and vision. And then was, of course, subsequently also a right question from interested member states. But then you have to tackle it very carefully to have it a success, to make it a success story. So, and then we invented basically together with member states the holistic approach. So where we take care about developing and deploying service provision components, basically the active part. The second one is taking care about preparation of the infrastructure. And here is very important. You can only service in an efficient way the infrastructure when the infrastructure elements are prepared for being serviced. So, and this is a second point. And the third one for creating a market and business is the legal framework. So, meaning we are also tackling this. We have a proposal at the table, European Space Act, basically, where we also think about to have, let's say, reasonable and light measures really to support business generation in this field while respecting the safety and security of operations in space. So this is the second thing. The third thing, and the last thing, this is very important, also addressed with member states here, is the dual use potential of this topic, which must be definitely discussed and further elaborated.
Yes, thank you very much. We will come back to this in a minute. Yes, Jérôme.
If I may just react on what I would like to pinpoint one word that you said, Daniel, is scalability. I think it's an important word because what we are doing together is scalable. And there is a difference of quantity and not of nature between what we are doing and an operational system, which allows to manage risk. And I think it's an important aspect towards our member states.
Thank you. Indeed.
Scalability. Talking about scalability, you have to start from somewhere. Christos, you started with a pilot, and you've gotten further. You have chosen the procurement process has been passed. Tell us a little bit about that, and where are you now?
Thank you for the question. Very interesting keyword, indeed, scalability. So, indeed, thank you, Jérôme, for introducing that aspect as well. And I'll get back to this in the little intervention I have here. So, just to start from where also Daniel stopped, this is going beyond the research and innovation and beyond the ambition, which is also to demonstrate some things in orbit. It's a seed for an in-space service infrastructure, and as such, it's a much more ambitious and wider initiative. Right now, today, we have started with the selection of research and innovation grants under Horizon Europe. However, indeed, the ambition here is in the next framework program to continue with something different here that allows us to create this architecture here, which will be actually a new space capability. And this is also why we have included this explicitly in our proposal for the next MFF, the European Competitiveness Fund, as it's called. Of course, now it's in the hands of member states at the trial now, so there's still a long way there. However, this is reflected in the Commission proposal. Maybe a few words on the mission, and then also to join about the cooperation and how we work together here. So this mission is exactly that: it's scalable, it's expandable. In fact, you have to see this as a coordinate system, XYZ, to which activities can plug in. And a perfect illustration of that is actually what you see on the screen with the different missions exactly put on that coordinate system. And here you see, one can see very clearly the huge amount of potential here to go faster together. And maybe a couple of words on the different components already. Thiago introduced them very briefly. One is indeed the servicing. It's the active part, as we call it, hosting. So this is the heart of the infrastructure, if you want. Logistics, the in-space transportation part, but also last but not least, what is called on the screen expanding It's called SATAPs. In fact, it's plug-and-play peripherals that can really change the way we operate in space and the way even we design space systems. Now, a word also on the implementation. Indeed, we have started with these grants at this stage. Very soon they will start. But it's important to also say that the approach is truly industry-led. So we've created a specific layer. We call it coordination support action. It's a specific type of activity that, in fact, is meant to really put together all the industry in all these different grants in some form, so that they are able to propose solutions, coordinated solutions about all the different aspects of the pertinence here. For instance, interoperability, one of the most obvious. And also now, before getting to the cooperation with ESA, very important to stress that this architecture has been drafted together with member states. And we believe this is actually a sine qua non condition. It's really a must to start this way. We see also a very high interest from member states, and indeed through a dedicated expert group we have created, this is the way we will go on. However, we also indeed, in order to accelerate everything, we would like to work very closely together with the colleagues from ESA here. Indeed, here are the possibilities for plugins, possible precursor missions, interoperability aspects where it is good to work in synergy to look at all this ecosystem as essentially one single ecosystem and try to join forces here in order exactly to accelerate, get faster to this capability that Daniel mentioned before, act in space, because indeed, actually our competition is outside Europe here, so we need to speed up.
Yeah, I think your final words will also come back later on. That our company, I think Jeroen opened the call conference with that tenor of being aware of what's going on outside of Europe. Thank you very much, Christos. I think in your short intervention, it was obvious that you're very committed in exactly this collaboration. But Tiago, coming back to you, plugging with interfacing with what Christos just said. How is working in the ISAM working group a bit in the more practical level with all the different elements?
So as I started saying in my previous intervention, we see ISAM being important for virtually every user, right? And the ISAM working group really came up as a need to make a coherent ISA vision across all directorates. So is actually, in my opinion, a quite nice example of how the one ISA should work. We have the chairing by both Ops and STS, in which we work very well together. Actually, if you look at this picture, it becomes very obvious also how, because basically what you see in the servicing domain is mostly the missions that are led by Ops, and what you see on the hosting logistics domain is mostly the missions that are led by STS, and we converge very well in these terms. So this working group puts together what we call service developers, STS and Ops, but it also brings together all the users inside these, all the user programs, could be telecommunications, Earth observation, navigation, etc. So the needs are also coming together from that level. And for example, when you talk about the SATAPs, the virtual user of SATAPs would be a payload for Earth observation that is plugged in a satellite after it was launched, etc. And at the same time, we also bring the technical expertise that is often taking lessons learned from all these different experiences, missions, and technology development. And this whole body makes the ISAM working group, if you want. So this is very important for us because it brings a unified ISA vision roadmap that then can also be used even when we talk with our partners to have a unified voice, but also to have a perspective of where ISA is going and how we can then, let's say, together adapt our plans to make a single vision. So when I talk about, in particular, topics like dual use or the SSIs, the standard interfaces, those are topics that are very important, of course, to build up together again, because again, if it is a telecom user or a EOP user, we want interoperability also in our services so that they can actually service whatever user is there. And we have achieved this through what we call task forces. They put together people again from all the spectrum, and they provide advice to our management and output. So we have as outputs things like the joint user roadmap. We have the interface developing and demonstration roadmap that could be built, of course, over time in collaboration with our partners and alignment with partners. So these are very important aspects that come together and come out of these task forces and this internal collaboration work with users and developers.
And I guess this working group is something permanent. It's not limited in time.
Yes, so the working group is permanent. The task forces are normally time limited with an objective.
With a certain
to produce
task.
a certain output.
Yeah,
yes.
yeah.
But
yeah.
in all of them, we try to have full representation.
I think it's very good that you think about user needs. And in this triangle between the institutional collaboration, what you're already doing, of course, our audience is representative from industry, R&D, and academia, and that they are interested in the current development that we all witness, the links and synergy. Yes.
No,
you wanted to add something?
Just wanted to say something that I think is important because we want to bring this internal coordination beyond the borders of ESA in this sense. And one of the things that we are also planning is to merge, maybe use this forum as the starting point for an ESA club, if you want, to have also unified communication with the industry, our partners outside.
So you want to connect the dots to
exactly
to the potential beneficiaries out there. This is what you're saying. Yeah.
Sorry for my intervention. I think it makes me think about one thing, what you say, Thiago, and I think it would be shared by our European Commission colleague. We want industry to be at the center of all this because we perfectly know that it's industry which implements. And we anchor all this ISAM process at ESA in reality and I would say daily life. Why I'm saying this? We have applied best practice from Space Transportation Working Group, and we would like to apply best practice from the space transportation. You know that in Space Transportation Working Group is a key process where, with academia, with industry, we are associating all the community to the decision and to the visibility of the way forward. And we would like to expand this best practice to the complete ISAM sector beyond pure space transportation. So I think it's important, the two messages, but maybe I'm anticipating a little bit on the ISO's contract, but we want really industry to be a partner, a strong partner, and this to be relying on lessons learned as well as best practice that we have been validating with in the real world.
Maybe if you allow me just to react on this, I think two points here also on the lessons learned in particular, and this is the reason why we put it under ISOs. Also, of course, we came both from the community of ISAM in the end, but we had always the feeling, at least at commission level, there was also two streams. One is focusing on the robotics only part, the servicing, assembly, manufacturing, while there's another stream that went under access to space at our side by that time, really like a last mile delivery, but then other in-space logistic component services. And that is why we had to connect here the dots, because we saw also similar stakeholder working on these areas, in both areas. So we said, okay, why not to talk about really, when we talk about Act in Space, capturing the space in between celestial bodies as potential future business room and business area, meaning here to connect the dots and talk about really in-space services. So basically, and then, okay, connect the dots and the links and put the hook towards any types of operations. We call it ISO, so in-space operations and services. So this is why I think this was a good move at our side, at least. And if happy to hear that you also would like to, inside ESA, to connect the dots, I think this would be beneficial also on the discussion with us So this is what I want to add.
And if I may add to that, indeed, I mean, Tiago also started with potentially thinking about doing coordinated events. Exactly. I mean, in our case, for instance, in the ISO Strategic Forum, which is, let's say, our equivalent of joining together the community, indeed, we have all the actors of this big architecture on the table, and our experience is very, very positive. Exactly that. There's much more to share than to separate.
Yes, thank you very much. As our time is always against us when we have interesting conversations, I don't want to leave you without discussing something that our audience is for sure very interested in. And this is the link and synergy to defense in general. And we had on different occasions today to touch on this. Maybe Christoph can start, and I would like really to I know time is very short, but let's talk about this, and I would like to hear your opinion.
Thank you for this question. Actually, we started discussing this this afternoon, so it was part of also the first panel. It's a very pertinent point here. Also, this is not only about tech being common. This is also about eventually seeing what services can be of use for the defense sector and governmental, therefore. So this is indeed fundamental active space for us, and it's also engraved into this architecture. This is open. It is, of course, also our pilot mission is a civil mission, civil derived mission. However, it is expandable indeed to defense users if they see the need. And here, maybe to also come to a very interesting word that was used this morning. This is exactly about creating synergies. It's not just about values or technology level. It's about creating synergies. So indeed, in our directorate, actually, it is the defense industry and space. So one concrete, very welcome development is that there has been a spin-off topic. This was traditionally a space development. There has been a spin-off to defense. So indeed, our European Defense Fund is also examining the concrete, more in the case of servicing, use cases for defense. So we're very, very much also looking forward that this activity also starts. It should be probably somewhere towards the end of this year, so that indeed then we can start working in concrete synergy.
Thank you very much.
So many things to say.
That
On
was
the duality, Christoph made a point on that, and I think it's an important aspect. I think we are only at the beginning of exploring the different dimensions of duality, because there was a point earlier on two sides of the same coin, or we see different approaches. Do we consider security defense consideration from the beginning of requirements? Do we start from a civil approach, then with adaptation? All this will need to be tackled and needs to be addressed in detail, because at the end of the day, very simply speaking, we are dealing with the same industrial base. There will not be civil, commercial, and here also for a reason of efficiencies, because we know that statistically 80% of the workload of the industry is civil, commercial, and 20% is security defense. And unless you want to buy an arsenal, you have to ensure the synergy so that you don't maintain a complete infrastructure that is loaded at 20%. So this duality has to be tackled. Overseas, they have a holistic approach. They consider national security as a whole, and there is no dichotomy between military, defense, you name it. And I was, in this sense, I was really very satisfied to see at CM25 that our DG and with the member states has devised an approach at ESA level to tackle the security defense, and we see it with a new program related to this that is in implementation. And I think it's really for us important to tackle this issue together with our colleagues. Thank you.
Thank you very much, Daniel. Maybe you and Tiago for last words on the topic. I'm afraid we're a bit out of time, but I think the audience will be interested to hear your opinion. And yeah.
Okay, thank you. So I think it's important, really, the step that we showed here today, really to go a step closer and align in that sense to not have duplications, but instead have complementary activities, and that we agree on something that we would like to reach at the end of the, let's say, tunnel or whatever you name it. So I think this is important. And we are especially happy also on our side that we saw that there's a lot of interest in the topics that we implemented via Horizon Europe, starting and kicking off basically this infrastructure development and at civil side on one thing, but also we have heard from our colleagues from defense, as many of you might know, that there was also a topic placed with regards to ISOS in the defense program 2025. Also there, we got huge interest in this topic of acting in space. So this is a good signal that we are not developing something here out in our boxes, let's say, and for nothing. No, we exactly hit the point where people are interested in.
Yes, thank you.
Well, then I'll just close by saying that I believe that indeed building this coherent roadmap that we are starting to do across organizations is really fundamental if our objective is to put European industry first. And here, I think by the scalability, by the interfaces, all the topics we touched in today, we are really talking about an infrastructure that has to be compatible, interoperational, safe for all these users. So I don't think, again, maybe echoing also what Jérôme said, there is necessarily a dichotomy here, but more the possibility of having a plurality of users and actors benefiting from a European infrastructure. So this is what we should aim at.
And with risk to be kicked out of the cocktail, I still would like to ask you, we with the credentials of the young companies before us, it was very emotional for the FLPP team to hear that the 3 months contract is possible at ESA. Within 3 months to fulfill a contract. I think maybe the audience has to applause once, please, because I think that's very important to stimulate. So to finish, what would be your wish that, Christos, to start with you, in like, what would be the word, maybe 1 or 2 words, speed or ambition or whatever, what comes to your mind, just what out of a spontaneous reaction?
Convergence.
Wonderful. Thank you very much. Tiago?
Collaboration.
It's
always
difficult. It's difficult. Well, I would say really forward-looking, just being forward-looking and what we are doing.
So now, Jérôme, thank you very much. Jérôme has the most difficult part, the last word.
Oh, no, it's not that difficult for me. It's very simple. It's call for action. Because we as a community, we have to go, and I look to all of you, industry, academia, institution, public entities. We have a prime mover advantage in Europe on this topic. But we have all to make our decision maker aware of the strategic importance of this topic in Europe. So my last 3 words is call for action to the community. Thank you.
Thank you very much. A big applause for my panel. Thank you very much for being patient. Kate, thank you very much.
Okay,
Maybe
so
we
I
make
will
a quick picture, right?
call the panel to move forward for a collaborative convergent photo. Okay, thank you very much, everybody. Thank you for that panel. Right, we have one last tiny section before we get to our cocktails. It involves another saying from me. Repetition is the mother of learning, the father of action, which makes it the architect of accomplishment. So this is Zig Ziglar. Basically, the point is most of you know already, a lot of you know how to work with FLPP. but we have some newcomers today. So this is why Agata is going to present once again how everybody can work with FLPP.
So thank you very much, Kate. I will try to make it short as most of you know it, but just to remind our process so that you, and also at the end, announce the course. So in terms of procurement process, we are essentially now open to competition. And this part is really very important for the very early activities. However, in some specific cases, we are also doing direct negotiation. This has not changed if it is justified. This is our process. Most of you know it. It starts especially for the early ideas through ideation phases, OZIP call for ideas, which you can find on the OZIP platform, and then we do the preparatory phases. This one is especially in terms of new initiatives. If we want to consult the ideas with ecosystem and have several contracts in parallel in order to see which way to go, and this is where we are mostly doing open competition. Further, we would go in the development phase, which means definition phases, implementation phase. This is where the budgets are going also up, and we want to have the continuation from the former process. So often it is restricted or direct negotiation. This is where we have also the limited group of stakeholders involved, but very often we are consulting the development within our ecosystem through the clubs, be it access to space or in-space transportation club. And this is exactly where, except the ITT, we are accompanying our industry and global ecosystem to consult the topics. So first one is the types of events you have today. We are doing it yearly, and first of all, it is to share with you the information on what is going on in FLPP. But the most important point is networking. We are gathering you here so that you have an opportunity to meet the ecosystem, discuss your topic, matchmake, open new collaborations. This event actually is about that. Then, in order to dig into more detailed topics, we have two clubs which are created today. First of all, one is Access to Space Club. Actually, it will have its second meeting tomorrow. And then In-Space Transportation Club. This one exists since 2 years, I think, already now. As I mentioned before, more than 600 participants. We are open for new. And this is the one which we discuss, as Tiago mentioned, with the ISAM working group in order to bring it at the level of ESA to aggregate all the participants who are interested in ISAM activities. And then we are also in collaboration with our CIC colleagues, connecting the industry to ESA Investors Network, and also connecting between primes and technology providers. This is where we are also accompanying the industry. What comes next? As you, Piero, mentioned before, in terms of initiating more calls related to the Ministerial Conference 25, we need to pass the element of implementation plan. This one will come around May, if I'm not mistaken. So for now, you have still opportunities which are linked to our former funding. And here, as Luis mentioned, first 7 structures, materials, mechanisms, and processes. This is the one which will be soon open. And very soon, ITT on INSPOC 4. So here, we are talking already about the ITT for the INSPOC 4. OZIP call is finished. And then in the Q3 2026, we can already announce that avionics and GNC next round will be initiated, and then wait for more to come end of the second quarter in order to see how other topics will be done. Announcement, as I said, event yearly. We hope to see you in October. This will be again in the same place as we had it last year in autumn in Salon de l'Aveyron. So it is near the Domenial headquarters of ESA. We really hope you to meet you there and that you profit of this occasion to meet European space transportation ecosystem. So please put it in your calendar. Events around this will be also organized, dedicated workshops, more information about this later on. Where you can find information, this you will receive within the slides. OZIP call, whenever we do the OZIP information, so this you will have a link where you can find all the opportunities. Very important website is a Space Transportation for Business. This is where you can find all the information about us and also on various activities we want to initiate. This is where also you will find a little bit of feedback after today's event. So please follow this website. And if this is the QR code, so this will be even easier to jump to this website, you will get this site, so you will be able to get it. And then always you can contact us also through FLPP contact email. Most of you know us personally, so you can also write to us directly. And last word on my side, I would like to thank a lot FLPP team and all the partners who supported us in organization of this event. For us, it's a very important event, but believe me, quite a lot of work. So that's why please do some or big applause for my colleagues. They really did an amazing job. Thank you very much for that. And on my side, this is it. See you in October, and I am passing the word to Kate to close the conference.
I think all I'm going to say is thank you very much, Agatha. Can we get a round of applause for Agatha, because she's done a lot of the organizing. So it's very simple. Thank you to everybody who's been following us online. Thank you to everybody here on site, and we can now go and have a well-deserved networking cocktail. Thank you.